All right, this is the three-part. We're going to write the formulas, recursive formula and explicit, and the thought process changes for each type depending on what you're writing. So let's start with the recursive, 6 and 7, and you first have to find the pattern of the numbers. So you're wanting to think, is it addition, subtraction, multiplication? What kind of pattern makes a 1, 5, 14, 30, 55? So it's a while to maybe figure that out, but you're just trying things. Uh, Add 4, is that the pattern? 1 plus 4 makes 5. Add 4, and you get 9, not 14, so it's not a plus 4 pattern, but that kind of thought process takes a while. But you want to be thinking in terms of previous term, a sub n minus 1, and current term, a sub n. So in other words, looking at the 5, what do you do to 1 to I came up with the plus 4 thought, but it wasn't plus 4. Now I'm going to shortcut the notes, going straight to the thought. You're going to, again, try a couple of things, but it's going to take a while to come up with this pattern. It is a plus 4, then a plus 9, then a plus 16, then a plus 25. And as you start to notice those numbers, 4, 9, 16, something might jump out at you, hopefully. Those are perfect squares. So I'll remind you that this is the first term, second term, third term, and fourth term, and fifth term. And using one set of numbers as an example, the 5 to 14, the third term, a sub 3, is equal to the previous term, a sub 2, plus what? What did we add to 5 to make 14? We added 9, which is, coincidentally, the 3 squared. Test that and see if it works in another pair, like the 55. Let me put the 55 on this side. A sub 5, aka 55, equals the fourth term, a sub 4, 30, plus what number? It was plus 25, right? Plus 25. So that, again, is that 5 squared. In other words, I'm going to try to teach this another way. Let's try building this set again. What would I add to 4? I would add 2 squared. I would add 2 squared to get 5. What would I add to 5 to make 14? I would add 3 squared. Notice it's the third term. I would add 3 squared. I'd add 9 to get the 14. To get the next term, the fourth term, what would I add? I would add 4 squared. I'd add 16. So I'm adding the value of n squared. In symbols, it looks like this. Any term is the previous term plus this number, whatever it is, n squared. And again, this is the most difficult part of the whole lesson of the reteach, that you just need a lot of questions in front of you to try this and to explore what the pattern is to come up with that. So this, again, will be the difficult part of the reteach. And you also have to define a sub 1 is 1, because if your pattern is going to take the previous and do this, you've got to have a starting point somewhere. So you always have to define a sub 1. All right, now let's try number 7. What's the pattern? Let's see, is it plus 11, then plus 33, then plus, well, because it looks like it's getting too big too fast. Let's try multiplication. Let's see, what if I and double it? So that would make 10 and add 6. So what if I double the 16? It'd be 32 and add 6. So it's not double it and add 2, but the pattern is actually triple. Confirm that. Triple the 5, triple it, so times 3, and add 1. Do you get 16? Triple 5, 15, add 1. Yeah. Now let's try it with the 16. Triple it, 3, 14, and add 1. All right, looking good. 49, triple it, 107, plus 1. So you triple the 148, and you get 444, and then add 1. So yeah, that's the pattern. Triple it, add 1. So to get, sorry about that. So to get any term, a sub n, you triple the previous, you triple the previous term, and then you add 1. That's the formula for this pattern. And again, you have to define the first term. The first term you triple is a 5. All right, so if the 13 and write a recursive formula for this pattern using what we just learned. You'll have to use a sub n and a sub n minus 1. The words are any term can be found equals the previous term. So think like that. What do you do to the 8 to make a 21? I pause the video, try addition, try combinations of the two, adding, multiplying, and see what you can come up with before I ruin the surprise. So again, hopefully you paused it. If you haven't, a little more time. The pattern from 8 to 21, it's not addition, it's not triple, but if you double the 8 times 2, you get 18, so you need to add 5. And that pattern is actually going to hold as well. If I double the 21 times by 2, I get 40, then add 5, that works. If I double the 47 and then add 5, I get 99. So you're doubling the previous, 2 times the previous, and then you're adding 5. Define the first term as 8. Take cursive. Again, it was such a small topic when we did that one's going to need the most work, more than likely. All right, these next 3, 8, 9, are writing explicit formulas. So it's no longer think about the previous term and what you do to the previous term. Now it's think about what do you do to the n value. So the first term in number 8 is a 4. The second term is a 7. Third term is 10, and fourth term is 13. You want to write those numbers above the terms and start thinking like this. What do I do to a 4 to make a 13? What do I do to make a 10? Do to those numbers, you're doing to n. So I'll let you think for just a second. The 4 to 13, I'm thinking add 9. I'm thinking 9. But then when I look at the 3 versus 10, I don't get 10 to 3, so it's not adding 9. So let's try multiplication. 4 times 2, 4 times 2 is 8, and add 5. That works. 3 times 2, 6, and add 5. No, that doesn't work. How about we triple the 4? Oh, okay, let's see if it works here with the 2. Triple the 2 and add 1. Yeah, it looks like it's working. All right, now here's a little thing that I need to show you at this point. This is an arithmetic. Plus 3, plus 3, plus 3. Our pattern that we're seeing is triple the n and add 1, so we're seeing a 3n plus 1 pattern. Triple the n, add 1. Well, since it's arithmetic, we can use day 1's notes. Put our a sub 1 here, n minus 1 times our d, which is 3, and distribute the 3, minus 3. Add the like terms, and you get 3n plus 1. So because this one's arithmetic, we can also see the formula should be 3n plus 1 to model this pattern. But the thought process, start playing with the formula, a sub n, any term can be found by taking 3 times the n and adding 1. All right, let's try number 9. Put the 1 up here, the 2, the 3, the 4, and the 5. This one probably won't take long to notice the pattern. What do you do to a 5 to make 25? What do you do to a 4 to make 16? You do to a 3 to make a 9. Itself by itself, right? You square it. So the pattern here, a sub n, is take your number that is n and multiply by itself, n times n, or n squared. So that's the explicit formula that makes that pattern. Number 10, 4, 9, 16, put these numbers 1, 2, 3, 4, 5 up here. But 4, 9, 16, 25, 36, those are the exact same numbers we were just looking at in number 9. But there's something a little different about them. It's not that you square the 5 to make 36. It's not that you square the 4 to make 25. So we've got to adjust our thought just a little bit. Instead of squaring a 5 to make 36, we need to square, right? Instead of squaring this 4 to make 25, we need to square. Instead of squaring a 3 to make 16, we need to square a. So we're formula just a little bit. Any term is in value. We're going to square something, right? Square a 6. So I want to take that 5 and add 1 to it. Add 1 to it. Okay? And then I want to square that. I'm going to have to use parentheses. 36. Yeah, okay. And then right there, 4 plus 1, I squared that. You need to where you're adding in before you square it. So practice writing an explicit on number 14. Start by putting 1, 2, 3, and 4 above them. Play with them. Addition pattern. Is it a multiplication? Is it a subtraction? A combination of both? It depends on the question. It may take longer depending on the numbers in it. So I'll let you sit and think for a second, and I will as well. So hopefully, think about it. And what you hopefully came up with, 8, 27, and 60, those are perfect numbers, or nice numbers, sorry, just like the 1, 4, 9, 16, 25 were. It's just they're not perfect squares, they're perfect cubes. 64 is 4 cubed. 27 is 3 cubed. 8 is 2 cubed, and 1 is, of course, 1 cubed. So to get any term in this sequence, you need to take the n value and cube it. So a sub n equals n cubed. All right, again, this is the hard part of the reteach, writing the formulas, and it just takes time, practice. So you may even want to do a few extra problems in the book or assigned in this section, chapter 9, section 1, to help out with that. But that does it for the notes.